Good morning, my lovely 13s. Right, buddies, here we are at the very end of our unit on moments in Year 13 Mechanics. How exciting! So, the only topic left for us to do is actually no topic at all. What I'm going to get you guys to do today is just to focus on absolute nightmare debacle, really hard moments questions that tie in all of the skills that you guys learned so far um, about forces and moments, essentially. So the questions that usually are the very hardest are ladder ones, because they always put the ladder on an angle, because ladders do go on angles, and there's a whole bunch of forces in them that are all going this way and that, so it's a little bit tricky, okay? So these kind of questions tie all of our skills together. So what we're going to do today is just try this one particular question together, this question 11 from the mixed exercises. So this question, I haven't tried it yet, I'm going to try it live with you, but this question should be very hard. It looks hard, and I would imagine it would be, because it's toward the end of those mixed exercises, so yeah, I can't even remember, it might even be the last one in the mixed exercises. But yeah, we're going to do one of these together, and then I'm going to try, and I'm going to set you guys off to try a whole bunch of really hard ones on your own. So here we go, buddies. Deep breath, get ready, get excited, here we go. Okay, it says a ladder, AB, is leaning against a smooth vertical wall, and it's on rough horizontal ground. At an angle of 55 degrees to horizontal. The ladder is length 10 and mass 20 kilograms, and a man of mass 80 kilograms. So it's the man is 80 kilograms, and he stands at C of the ladder. Given that the magnitude of the frictional force at A is 20, find the distance AC, which is to do with the man. Model the ladder as a uniform rod, which is good. That means that the mass is acting at the middle, don't forget. And the man is a particle. The man being a particle just means treat all of his weight as though it's over 1 point. Yeah, that's a good assumption anyway. That's cool. Right, so what do we do then, buddies? What do we do first of all? That's it. You have to draw a picture, okay? So I like the picture that they've given us, but they don't always give you a picture, and yeah, let's draw a picture. Okay, so we can largely nick that picture, but let's do it. Okay, I'm gonna make mine nice and big because I know this question could potentially be a bit tricky. So I'm gonna draw my ladder, but I'm gonna draw it 2D, so it will remind me that it has mass, okay? So it reminds me that it's not a massless ladder. Cool. What do I know about the ladder? I think I know that it's 10 meters long. So it's 10 meters long, the ladder, from the question, from there to there. I know that it's got a 55-degree angle up with horizontal. So 55 degrees is there. And I think that that's all I know about the ladder and stuff. I think that that's pretty much it. Oh no, it's not everything. I know that the ladder is called AB, which means it goes from A to B. And I think that that is everything I know about the ladder. Okay, cool. So here we go, my buddies. There's also a bloke on it, and the bloke is at C. I'm just going to put the bloke, I don't know, there. Okay? Not quite halfway up. I'm going to draw my bloke bigger than that as well, because I can't write the word 80 in that. So here we go. There's our bloke on the ladder, and he weighs 80 kg. Yeah, that's right, isn't it? Yep, he's 80 kg, there it is there. He's 80 kg, and that's it. Now, I think that's all that there is to do with, like, the physical side of this question. Now, here we go. I know the forces are given, but I think we'd do well to talk about them anyway, despite them being given. So, tell me right away, tell me one force that you can think about. Well, yeah, there's the man on the ladder, right? So, we've got him straight away. There is the weight of the man. Any other kind of forces on it? Well, yeah, there's the weight of the ladder as well. Okay, now I don't quite know where the man is on the ladder, but I know that the ladder itself, center of mass, is there. How far is it to the center of mass of the ladder? Well, yeah, 5 meters, because it said that it was a uniform rod, which means that the center of mass is in the exact center. Cool, what other forces are there? Well, it says there's a frictional force that's 200 newtons. Here's what that's going to... So I know it's given on the picture, but I wish it wasn't. Okay, if it's given on the picture, check it out. Here's what you've got. You're going to get that force there, and I'm going to call that FF for the force due to friction, and it's 200 newtons. Okay, now why would the force of friction be acting that way? Well, because this force of friction opposes motion or intended motion. If the floor was slippy, the back side, the bottom side of this ladder, would slide out toward the left. So what's preventing that? A force of friction pulling it to the right. So there's your force of friction included. Now, here we go. There's another force as well. It is touching the floor, so there's a normal contact force, and that goes vertically upward. Now, not everybody knows that, but I'm going to call that RA. Okay, not everybody will know that the contact force goes vertically upward. But the thing you've got to remember, my buddies, is normal contact forces is always perpendicular to the surface, okay? So ignore the ladder. The surface that the ladder is touching is the floor. So perpendicular to the floor is vertically up. So that's why RA is there. Now, you know that force of friction is mu r as well, right? We know that the force of friction is linked to the normal contact force. This force of friction will be linked to this contact force. Cool. Now, there is another contact force too, because it touches the wall here. Which direction will that act without cheating and just looking? Well, that's right, it's going to act left. Cool. This one acts left, and again, it's because it's perpendicular to the surface. Now, it does say that the wall is smooth there. Okay, that's unusual. Walls aren't actually smooth. I think they've done that to try to help you, to be honest. But there should be a force of friction, which there won't be. So I'm going to draw it, but then I'm going to erase it. The ladder would like to slip down, right? 9 times out of 10, there'd also be a force of friction that way, acting upward to prevent it from slipping. But the wall's smooth, so there isn't friction there. Just that. So there's our whole picture, buddies. Cool. What are we actually trying to figure out? Well, it says the man's at C, and it wants to know the distance to the man. So actually, we're after this, x. We want this distance that goes from there all the way back to A. That's what we're after, because it says the distance AC, and it says that the man is at C. Cool? So the distance AC is that. Cool. Now, this is a handful, is probably what you're thinking so far. You might be thinking, oh my god, there's a lot of rubbish on here, and I don't know what to do. Here's how you approach all the questions that make you feel like I don't know what to do, which is most when you get to wait till you get to university and try these. You'll see every single time you look at a question, you'll be like, oh my god, I haven't the foggiest. But you approach them in the exact same way that I'm about to approach this. Just try to figure out, say to yourself, well, what am I after? I'm after X. Is it going to be moments or is it going to be forces that gets me X? Well, it's going to be moments because that's the one that's got X in. So whilst I have no idea about anything in this whole question, I'm going to start with moments because I know that that's potentially going to lead me to something with X in. So here we go. We're going to take moments. X starts at A, so why not hinge at A? Hinge at A. Cool. It's not slipping, so anti-clockwise is going to equal clockwise. Cool. Now, it's going to be a bit tricky though, still. And here we go. Which of these forces then are going to make it go anti-clockwise if the hinge, my buddies, is here? Oops, it should be red. Oh yeah, there it is. If the hinge is there, which of these forces is going to make it go this way around? Well, RA and FF both don't play a role because their distance to the hinge is 0. And you should see that it's just RB that wants to make it go this way around. The other ones want to make it spin the other way. So left-wise, like anti-clockwise, you're going to get RB. Okay, that's going to make it go around. Now, the thing is, what is the shortest possible distance now to the line of action of RB? Is it 10? No, it isn't. See, this is why this is a really hard question. It's not 10 actually, my buddies, is it? Yeah, it's a bit of a nightmare. Check it out. Remember, it's the shortest possible distance to the line of action of the force. That's the infinitely long line that follows RB. So the shortest way to get to the line that RB is not up here, not on the diagonal, but actually vertically upward like this. That is the distance that we need. How in the heck are you going to get that? How in the devil are we going to do that? Well, I'll tell you, my buddies. Here's how you're going to do it. Can you see? Oh, if I draw this all as one highlighter, I'll be able to erase it later. It's all down to this triangle. Okay, now I'm just going to go up here so I can erase it later. Okay, it's all down to this yellow triangle that I just drew. That's the distance to it, okay? Well, if this is 55, then you got his angle that this is 55 degrees too. It's like an alternate angle, isn't it? Because they're on opposite sides to each other. It's the Z angle from year 8. So there you go. It's a right angle there as well. And oh my gosh, that's not too bad then. The hypotenuse of this thing is 10 because 10 was the length of the ladder and this is the ladder. So the hypotenuse is 10. So it's just going to be, my buddies, 10 sine 55 to get this opposite one. Does everybody follow? Because it's like sine 55 is going to be like the distance, h I'll call it, over the hypotenuse, which is 10. That's where that's come from. So I hope that's okay, my buddies. Get it, get it, get it? That's the hardest part, I think. Cool. Right, I'm going to bin off the triangle now just because it's confusing. Got it. Okay, that's the anti-clockwise force. What's going on with the clockwise forces then, my buddies? Well, there's two of them. There's going to be the weight of the ladder to start with. And what's the shortest distance to the line of action of the force of the weight of the ladder? Is it 5? Well, no, it isn't again. Debacle, my buddies. It's not, is it? It's another one of those palavas. The line of action of the force is this line that goes infinitely. So the shortest distance to it is now going to be, and I'm going to erase this triangle too, it's going to be linked to this triangle now. Yeah, buddies? It's going to be linked to that one. The distance is actually this, along the floor. So it should have been 5. The hypotenuse is 5, but it's got to be along the floor. Cos 55, because that's how you meet the line of action of the force to the hinge horizontally. Can you see it? I hope you can. Cool. That's good. Right, and the same deal again at the man. You do the man, though. You can do him. Go. And if you wrote this, you're probably, which I bet you did, is this. The weight of the man, and what's the shortest distance to the line of action of his force? Well, x is the hypotenuse. It's x cos 55. I hope that you see that. The man's triangle is this triangle. And his line of action is a downward one, just like that. So his hypotenuse is x, and it's still cos 55 because it's only adjacent. Cool beans. Right, let's see what we got. So here's what we've got. 10 sine 55. It's got RB in. That's bad because I don't actually know what RB is, so that's terrible. WL is fine, the weight of the ladder, because that's given, and that's just a number, so that's a result. The weight of the man is given as well, so that's a result as well. So I'm happy with those two variables. I'm unhappy with RB. I'm happy with that. I'm happy with that. And I'm happy with the x too, because that's what I'm solving for. So here's the, do you see what I mean? Like when you don't know what to do, you just jot something down and then you see how it goes. Yeah? So the problem is I don't know RB. Shoot, how do I get RB? What can I do? Well, yeah, forces are in balance as well. I mean, you could hinge at the middle or something if you wanted to, but you'd be mad. That's really hard. Why would you do moments when you could do forces? Forces are easier. So here's what you're going to do, buddies. Now we're going to balance forces. Yeah? So here's what we're going to do. We're going to consider a direction. Hor for horizontal. Pick whatever way you want to be right. Left can be right, just to make it funny and confusing. Do your F-net equations. Horizontally, here's what we've got. F-net is going to equal, and left-wise, we've got RB. Right-wise, we've got take away 200, and everything else is vertical. Yeah, the other 1, 2, 3 are vertical, so it's just those two forces. Now, is the ladder accelerating? I hope not, otherwise the bloke is in trouble, so F-naught is 0, which means RB is 200. What a result! You could make this question harder by putting friction on the wall and stuff, and that's kind of scuppers things up a little bit, but it's neat this. They could have also not told you what FF was. They could have made you calculate it, but yeah, that's kind of the trick to this question. Well, sick! You've just sorted out the one thing that's wrong with the question, so the rest of it can just fly now. You ready? It's 200 times 10 sine 55 equals the weight of the ladder. The ladder was, how much did the ladder weigh again? The ladder was 20 kilograms, so the ladder is 20, but don't forget, times 9.8, because mg, and then this is times 5 cos 55. Then you got your weight of the man, who was 80. Don't forget, it's weight as well, it's not just mass, so times 9.8. And then you're going to be times by x cos 55. X cos 55. Now, you can do this in one step in your calculator, and if you feel comfortable to do so, like, go ahead, do it right now. I'm gonna, because I'm worried that not everyone will get it straight away, I'm gonna put the steps in so you can check as you go. So 200 times 10 sine 55 equals 1638.3. 1638.3. So my answer might be off by a few decimal places. That's okay though. 20 times 9.8 times 5 cos 55 equals 562.1. 562.1. And this one here plus 80 times 9.8 times cos 55. And so I'm just ignoring the x really. It's 449.7. 449.7 by timesing these 1, 2, 3 things together, and then pop your x on it, and now hopefully you can see how to solve it and no problem at all. Final answer, x equals, let's do it, 1638.3, take 562.1 equals divided by 449.7 equals, I think it's 2.39 meters. So for this situation that it describes, how far is the bloke up the ladder? Well, 2.39 meters. Not bad for 15 minutes worth of one question. Oh, insane, my buddies. But that's how it goes. That's what you got to do. You got to be good at drawing these pictures. You got to be spotting lines of action. You got to be looking for shortcuts. Can I do forces and balance? Can I balance forces rather than do moments, which are a little bit harder? Yeah, you got to look for all these things. So I'm going to stop yipping now. I'm just going to let you get to work. And here's what I'm going to have you look at it. We're not actually going to do these questions, don't worry. I picked this question out. This is just one of the examples of these like exam-like monstrosity questions that I've seen in the past, okay? Here's an absolutely nightmare, horrendous ladder question. So have a look at that, have a go at that, and that's what I want you to have a little try of. But just so you know, I've attached the worksheet. It's the MEI Integral at Excel Topic Assessment. So I've attached it and its solutions. Do your best not to look at the solutions. This is question 2 on that sheet, so you don't have to do it with the video paused or anything. You can go and look at that sheet now, and just make sure you get onto this one, okay? Because that's tough, and if you can do this, you can do all the moment questions. Yeah, so I hope you enjoy, my buddies. I think these questions are quite fun. I don't think that I've asked you to do something horrible. I think I've asked you to do something fun. So good luck in trying to work through that. And I guess that's it from me. See you next time. Bye, buddies!